Sliding filament theory. The sliding filament theory explains the mechanism of muscle contraction based on muscle protein that slide past each other to generate movement. According to sliding filament theory, the myosin filaments of muscle fiber slide past the actin filaments during muscle contraction. We are able to do so many movements in our daily living like walking, running, pushing, pulling, etc. This whole physical activity happens as a result of muscle contraction. And understanding the structure of skeletal muscles is useful when learning how sliding filament theory works. Skeletal muscles are surrounded by the epimysium, which is the outer layer of connective tissue of the muscles. The muscle is then divided into muscle fibers, where a bundle of them is known as fascicle or a fasciculus. This fascicle is covered by the perimysium. Each fiber that is held within the fascicle is covered by an endomysium. These connective tissues work together to transfer force from the muscle to the bones. Every muscle fiber is surrounded by the sarcolemma, and myofibril is bundle of myofilaments made up of both actin and myosin. Actin and myosin, these are the filaments that we use for contracting muscles. Within actin, there is both tropomyosin and troponin. There are many steps in sliding filament theory. When a nerve impulse received, the cross bridges of the myosin pull the actin filaments towards the center of the sarcomere and tension is created. The sliding motion between the actin and myosin causes the shortening of the sarcomere and as well as the entire muscle fiber. The action potential goes across the length of the neuron, which leads to the releasing excitatory neurotransmitter acetylcholine in the neuromuscular junction. The acetylcholine moves through the synaptic cleft and it then binds to the acetylcholine recipients on the motor end plate of the fiber. This now leads to an action potential within the sarcolemma generating. The T-tubulus take this action potential and the release of calcium starts from the sarcoplasmic reticulum. When this calcium goes to the sarcoplasm, it goes to the troponin molecules to bind. These are found along the actin filaments. The binding causes confrontational changes in the troponin's shape. This now moves the tropomyosin and exposes the myosin heads. When these binding sites are exposed, the ability to attach and make a cross bridge will attempt to pull these filaments to the sarcomere's center. Moreover, the nerve impulse that applies to the muscle cell, regardless of its strength, causes the sarcomere to contract maximally or not.